So what exactly is core data? Core data is essentially a framework to help you manage the model part of your app. You recall that the model, view, controller design pattern splits your app up into 3 parts, and that the model part is what deals with the important, tangible, essential pieces of the app. Core data gives us a way to manage these important pieces and gives them the title Managed Objects. What does managing these objects entail? It includes everything from changing them, tracking them, persisting them, to managing their relationships and more. Let's look at an overview of the core data architecture to see how this works. There are several main components to become familiar with, and we've already somewhat touched on 2 of them. The managed object model, also referred to as the data model, is basically the physical representation of the model we just spoke of. It exists in Xcode as a special kind of graphic file, similar to a storyboard file, but with different purpose and capabilities. The managed object model is what is used to specify the classes and relationships that will be managed within your app, and is therefore also what the tables and rows of your app's SQLite database will be generated from. Much like how Interface Builder automates a storyboard file, Core Data automates a managed object model file. Managed objects are those important fundamental pieces we spoke of earlier. A character in a game app, an event in a calendar app, they're what's specified by your object model and what are actually responsible for most of Core Data's magic. See, while they look like regular Swift objects, they have a substantial twist. Unlike any object we've seen thus far, they save the contents of their properties to a database file. Core Data actually hides this complexity from us, so we don't have to worry about it, which is why we refer to it as magic. Every single object of your model will be a subclass of NS-managed-object. The managed object context, or the context, is where most of the action happens. This object, an instance of NS-managed-object context, is helpful to imagine as a place. The context is where your managed objects live until they are saved to disk, and where nearly every core data operation takes place. Want to create an object? You need a context in which it will live. Want to delete an object? Ask the context. Want to save? Again, ask the context. To find out who and what is living inside the context, a fetch request is needed. A fetch request is a search of the context for a certain type of managed object. It can specify the type of managed object, a filter, and how the resulting objects should be sorted. All of the pieces of core data that we've discussed thus far have belonged to the model layer. This next piece, the fetch results controller, works in part to control how the data from the fetch request will be displayed in a view, and is thus part of the controller layer. A fetch results controller takes a fetch request, runs the search, and helps display the results in a table view, or with a little extra work on our part, a collection view. The most basic task a controller must perform is to keep the model and view in sync. An NS fetch results controller does precisely this. If the objects returned by the fetch request ever change, the fetch results controller automatically updates the table view. At the lower level, core data relies on what's called persistent stores, or stores for short. Stores, like the name implies, are where managed objects actually get stored when saved to disk. They can be thought of as database data files and can exist in several types, namely XML, binary format, and SQLite, the latter being the most common and also the one we'll be using. Note that you can have more than one store or type of store in a given app. Also at the lower level is the last piece we're going to talk about for now, the persistent store coordinator. This object allows you to have multiple stores and keep the rest of your app from knowing it. But for the most part, persistent stores and their coordinators are not something you have to worry about too much. These classes, when put together, make up what's called the core data stack.